Okay, so we have started line integration in last class. So let me start today with an example of line integration. So what you have done, that integration over C some f of xy dx, or maybe dy, maybe sometimes ds, like this. So this type of integration we have crossed out. So now here we have an example, integration over C yz dx zx dy plus xy dz, and C is given the curve in parametric representation. When is parametric representation is given, it is much easier to solve. So what you need to do, simply just put down these values. T has given the value 0 to 1. So as x is given t, so you can find from here dx is equal to dt. Then similarly y is equal to given here t square. So that implies dy is equal to 2t dt. Then z is equal to given t cube. That implies dz is equal to 3t square dt. So we have dx, dy, dz, and x, y, z. All these value we can have. So we can write the integration as, integration over c. I will replace this c by t later. First yz, y into z means y into z, y into z. That is t square into t cube. That is t to the power 5. Dx is equal to dt plus zx. Zx is equal to t to the power 4. So t to the power 4 into dy, that is 2t dt,
2t.
plus last one is z xy,
So
x into
3
y, that
to
is
the power 5. 3 to the
uh,
power
T
5.
cube, sir.
t cube into 3t square dt. And as all converted to dt, so t is this integration over t is given from 0 to 1. So you just simply write 0 to 1 t. Now just simplify this and get the value 0 to 1. This will, sorry, 0 to 1
It will
t.
be 1, sir. 1. The
So
value will be
whatever you
1.
just
Power
you can
5.
you can get the integration. 2 to the power 5, all are 2 to the power 5, no, 3 to the power 5 and dt. You can get this integration. I think you can do it. Okay. So when parameter, so last we have discussed that the curve, the most important part is the curve. You have to judge the curve part. The integrand is not much more important. Important thing is that the curve, how this curve look like. If the curve is a straight line or parabola or some parametric representation is there, maybe sometimes circle will be given. So if it is possible, my suggestion is that, not, I'm not saying this is the closed rule. I'm suggesting you that if it possible, make just get down the parametric representation of the curve. Then the thing will be much easier. Suppose the curve is given as x square plus y square is equal to 1. Suppose a circle is given. So what you will do? Try to get its parametric representation. So I can put, you see, x is equal to cos theta, y is equal to sin theta, cos square theta plus sin square theta is equal to 1, and theta runs from, so a closed circle, one full circle is given. So in that case theta runs from 0 to 0 less than equal to theta less than equal to 2 pi. Suppose it is given the curve is lying only in the first coordinate, that is here. Suppose this curve is given over here only. So in that case, x is equal to cos theta, y is equal to sin theta, and theta lies from 0 less than equal to theta less than equal to pi by 2. I can,
Pi by 2.
in this way you need to do. Suppose the curve is given x square is equal to 4y square. So what we will do? X square is equal to 4y square, and suppose it is also given that 0 less than equal to y less than equal to 1. Something is given like this. In that case, what you need to do? Put y is equal to t over here, x is equal to, in that case, 4t square, and as y is equal to taking t, so 0 less than equal to t less than equal to. Try to get its parametric representation. if it is possible. If not possible, sometimes some triangle is given. Suppose the curve is given like this, that from uh, A to B to C. Suppose the curve is given like this. So I will have an example, I think, like this. Yes, see, come down to this. You see very carefully. The problem is very much easy. Just try to understand what I am doing here. So what you need to integrate, integrand is x plus y. That is not much more important. Thing is, we are integrating with respect to x. You see, we are integrating with respect to x along the curve gamma. We are integrating this x plus y line integration along the curve gamma and with respect to x. What is gamma here? That is important. Gamma is be the two line segment. There is two line segment, combination of two line segment. One is lying on y is equal to 0, that means x axis from 0 to 1. Another is portion is on y axis from 0 to 1. So try to draw it. So I am writing like this. So the curve is, what is the curve? Suppose this is the origin 0 0. So first segment is y is equal to 0, that is x axis from 0 to 1. Suppose this is 1. Suppose this is x equal to 1. So first segment is this one, and second segment is on lying on x equal to 0 from 0 to 1, y is equal to from 0 to 1. So like this. So the my line segment is, if I denote this point A, this point is B. So line segment is suppose OA and OB. You may take from BO to OA, no problem. I mean, whatever the direction you can just write. So it is given two line segments. So from A to O, so I can write gamma is equal to what? Gamma, this curve is equal to actually the line segment AO plus the segment OB. So integration gamma x plus y dx, that can be represented as integration along AO x plus y dx plus integration along OB x plus y dy. Sorry, not dy, dx. Fine. So now see, along AO, along AO, along this line AO, what we have,
Y
you
equals to
see,
0.
x changing from 1 to 0. Okay, let me complete. Suppose A is x running from 1 to 0 and y is equal to 0 always. So x running from 1 to 0, x is a variable, y is always constant, is 0, then dx. And second part, in OB, you see y is changing 0 to 1 and x is fixed, x is 0. So y is changing from 0 to 1, x is 0 plus y. In that case, dx will be what? Dx will be 0, yes or no?
0,
As
0. Just
0,
0.
Yes, sir.
dx is equal to 0, that means this integration part will be 0. This integration part is going to be 0. Have only this one. So just integrate this. This will be minus 1
1
by
by
2. No?
2.
Minus
Minus 1
1
by
by
2.
2.
So the value is minus 1 by 2. Okay. In that case, parametric representation should not be much familiar. So in that case, we will do in Cartesian form. Okay.
Sir,
हाँ बोलो.
sir,
बोलो.
sir, actually, how we are assuming that x runs from 1 to 0, we can also assume that x runs from 0 to 1, or
No.
we can
Yes,
assume
sir.
that
Given
BO,
so
See,
the
given
curve is
this,
position
along
in the
BOA.
this is a
general
continuous line.
1 by 2.
Let me see. Let me tell you. This is a continuous line, na, curve. See, continuous. You cannot say that the curve is 0 to A and then 0 to B. Not like this. Either you have to start from here, you have to complete it here, or you have to start from here and complete it here. This is the two only ways.
Yes, yes, sir.
I,
That's what I am
so
saying. We can
But
start
sir,
from
if we
B.
so
say the
in that case,
BU,
you just take, no problem. You can take from B to 0, 0 to B.
Yes, sir.
The only sign is change, nothing else. Only sign
Yes,
will
sir. The
change.
value will change only.
Value
Yes,
So
will
yes.
be
then the
1 by
answer
2.
will be mod 1 by 2 because
No
both
need to
plus
write
and
mod 1 by 2. No need to write, just minus 1 by 2 you can write. It is given only line segment, so you can write. Both are correct.
Sir, can we consider it in the opposite direction, like from B to O and O to A?
Huh. But the thing is given, I am writing because y is equal to 0 first given, that's why I'm taking this one,
Okay.
nothing else. As the problem is given, as the demand from the demand of problem.
so but sir, but if the
But sir,
direction
the
changes,
limit.
then the sign will change. No, the sign will change. It will become half.
Sign will change. I appreciate that. Sign will change. Only the sign will change. The value will be same.
But will that
So
bring
so
any error, sir?
No,
yes.
no, no,
Sign
no,
is
no, no
changing.
error. Both are
Sir,
same. Both.
sir,
Sir, I
is
think the direction will be
representing an
mentioned
area.
in the problem itself.
Yes, correct. The
Because
problem
Means
as
in
the
physics we used to
uh,
calculate work done by
yes,
a
yes, yes,
arbitrary force,
yes,
so
yes,
there
yes.
was coordinates mentioned.
The problem will be must be this as the if the problem is given like this. So you can, as the problem is given like this, so you can take any direction, no problem. Problem, if it is problem is given that first the line segment from A to 0, then the 0 to B, then you can write this. From this particular type of problem, what how it is mentioned, you will be having the value either minus 1 by 2 or 1.
so then we will have to take out both the values because they are
No need
like
to take both the
minus
just
plus.
no need to take both the value. Just to do one, any one,
Okay, sir.
but don't take O to B and O to A.
No, sir. That
Okay.
won't be continuous.
Huh. So next, I've given some problem. I've given some problems. I will supply it to you. You go through this problem. If you have any query, you can ask me in that case. So I've given some problems to you. Please, all of you, mute your microphone. Okay. Now we'll start double integration. That was the line integral. Now double integral. So how will consider this double integral? Suppose suppose we have the x-axis over here, the y-axis like here, and this is suppose z-axis. Okay, and the integration we write represent a double integration over a region. Previously we have integration over a curve, integration along the curve. Now integration along a region. Okay, and you have to integrate some function, suppose f of xy, with respect to some area dx dy, some area. Previously we integrate line segment, here we will integrate in area. So what we will do, the thing will be like this. Suppose we have a, first we consider a rectangular like shape. So consider like this is your r, suppose this is your r region, this is your r. You need to integrate along this line, along this region. What you need to integrate, integrand is f of x. So f of xy is what, is some surface like this, some surface like this. Suppose this is your z is equal to f of xy. So what you have to, so you have to integrate this f of xy, this z is equal to f of xy along the region, along the region lying in xy plane, lying on xy plane. So as this region lying on xy plane, so you have to integrate with respect to this dx dy. So what we'll do first, in line integration we have the curve is separated in some very small parts. Here also we the region will be subdivided into some small areas like this. Suppose we have like this. Consider this rectangular curve R, A less than equal to x less than equal to b, and C less than equal to y less than equal to d. Suppose. So we'll subdivide this interval into some point x0, x1, x2 up to xn, and y0, y1, y2 up to yn. So suppose these are the y0, y1, y2 like this, and here x0, x1, x2 like this. So we'll be having very small surface, small region like this, subdivide like this. Okay. So now if you take arbitrarily any surface portion, like suppose this one, if you take this one, so I'm taking a surface, this sorry, suppose this x0, x1 up to xn, I am taking this is xm, y0, y1 up to ym values. Now on this portion, if you take the projection over this z, so what will happen, we'll get a very small volume like this, will get a small, very small volume like this. So this region, this portion, this region on xy plane, suppose this portion, the area of this portion represented as delta ij. What is delta ij? Delta ij is the area of the ijth rectangular shape. So delta ij is the area of the ijth rectangular shape. Now if you take, suppose I am taking out this one here, suppose this is your delta ij area. Suppose there is a point here, which one is xi ij eta ij. There is a point over here, that is di ij eta ij, and we are writing a we are taking a projection on this f of xy. So what will be the value? The projection value will be f of a, sorry, f of xi ij eta ij. This will be the length if you take this projection length. Now if it's multiplied with this area delta ij, what will get? Will get the volume of this portion, volume of this small portion. And if you take the summation over this ij from j is equal to 1 to m, summation from I is equal to 1 to n, if I take the summation, that means whole area will be given. And consider delta is equal to maximum of this delta ij's, maximum of this delta ij's, and take limit delta tends to 0. This actually represented as the double integration r f of xy, delta ij is, as delta ij we are taking on xy plane, so the area actually represented as dx dy. If we take this region on yz plane, then this will be dy dz like this. So this represents the double integral. Now what we'll do,
Excuse
how
me,
to
sir.
हाँ बोलो बोलो.
Sir, can you again explain that eta ij
Not
and
getting, not
eij?
get.
That so can you
This is
again explain the term
any
that eta ij?
let me in line integration, you see over the xy plane what we are taking there, x0, x1, x2, these points xn, and in between suppose some xi minus 1 and xi, in this interval there we have taken one arbitrary point xi I, just recall, and then we are taking
Yes,
the
yes, sir.
projects on this curve that we defined as f xi, this
Yes, sir.
thing, and that was multiplied this one that represent the area, the rectangular
Yes,
area.
sir.
Here it is representing the rectangular volume f of xi eta, f of xi ij eta ij, that is the projection, this line, some line over here, let me take some another color. We are actually perpendicular line, straight line like this. This is actually f of the value of this f of xi ij eta ij, that is multiplied by this area, means what? That is the volume. So this is
Yes.
the small volume we are taking here, and this small volume, if you take summation over all ij, that is all this cylindrical volume, if you take, so that will be the summation, and that actually we are finding. So this actually represent the area. This actually represent, this integration actually represent this volume,
Volume.
this volume represent this volume area, actually representing this volume. Okay, this is represented by this r f of xy dx dy. It okay? Now,
Yes. Sir.
okay, now let me go through iterated integrals. So what do you mean by iterated integral? Actually, you see, why we will require this iterated integral. Listen, we are integrating over r f of xy, suppose dx dy. This is a double integral. Now double integral can be represented as iterated integral. So what is iterated integral? First, suppose first we integrate this f of xy. First we integrate this f of xy with respect to suppose x. If we integrate f of xy with respect to x, considering y as constant, y is a fixed value. For each fixed value of y, we can integrate this one. And suppose the region R is, this region R is xy, a less than equal to x less than equal, sorry, a less than equal to x less than equal to b, c less than equal to x less than equal to d. Suppose, so in that case, if we integrate a to b f of xy dx, so we are integrating with respect to x. So this function will be what? A function of y only? Yes or no?
Sir, I couldn't understand the limits.
Uh, Suppose the region, this rectangle region, is given as xy, a less than equal to x less than equal to b, and c less than equal to less than b. Means what? Suppose this is your xy plane. X runs from,
So C less than Y less than D.
Sir, exactly, sir. Will
Yes,
it be
sir, I
y?
think that
C
would be
less than
y.
y less than.
Just
The second
oh,
one
okay,
is y.
okay, sorry. This was y. This is y. Oh, sorry. This one is y. Now it is clear.
Okay, sir, now it's clear.
Now clear.
Yes,
Sir.
sir.
Okay. This portion actually, I am telling about this portion. Okay. So if you integrate from a to b f of xy dy, so if you integrate with respect to x, that will be completely a function of y. After that, whatever you get y, if you integrate with respect to y now, c to d, then we'll integrate this one, c to d dy. That will be the that will have some value. So this is known as iterated integral, and that represented as c to d dy a to b f of x dx dy dx. This means what? This actually means first integrate with respect to x. This iterated integration means first integrate with respect to x like this, then whatever you get, that you integrate with respect to y. So this is the notation, c to d dy a to b f of x dx. So what does it mean? It is mean that first integrate with respect to x, and whatever you will get, that will be a function of y. Then again you will integrate with respect to y. So that is known as iterated integral. Okay, iterative. Similarly, if you integrate first with respect to y, then with respect to x, then it will be c to d dx, sorry, a to b dx, and c to d f of xy dy. I've written down all these things in next page. Before going to that, now there is a theorem. No need to remember like this theorem, just simply try to understand that we can write. This is required for the problem. No questions will be there from theorem. So what? Suppose this double integration f of xy dx dy exists over a rectangle R, and this integration exists for each value of y in C to D, then this repeated integral this exists, and we can say this will be equal to this region. So actually when you are asked to find the region integration this f of xy dx dy, first we convert it to a repeated integration. So you can write in that case, so R is what? R range will be a to b. You need to check from here. Sometimes integration range is a to b, sometimes it may be some function f of y to some g, like this. So first you need to check the region. So this can be written as C to D dy integration a to b f of x y dx, or you can write a to b dx integration C to D f of xy dx dy, provided both this integration exist, provided both. It is not always true that this both integration will exist and equal. It's not always true. If both are equal and exist, in that case only we can write this thing. So that we have in our next slide. We have written down there. So this is the first thing, whatever I have discussed, that you can represent like this thing you can represent like this. And here, if f of xy integral over this region R, and if all these two integration exist, then only this will be okay, what I have just said. And in that case this will be equal to these two things. Okay, all are equal. And there is a point corollary 2, that if it is possible to represent f of xy as a product of two functions, some phi x phi y, or you can write psi x phi x psi y, two independent function. In that case you simply write this integration will be equal to a to b phi x dx c to d psi dy. So these are the, actually you can write as a, consider as a property, that this value, you need to find this value, you can multiply these two things. Okay, so these are some things. Now just let me go through one example, it will be more clear. Now all of you, are you hearing me?
Sir, can you please show the previous slide? I need to copy.
Yes, sir.
Yes, sir, we can hear you.
Bolo. This one? Hello?
Yes, sir. Yes, sir.
प्रीवियस वाला भी दिखा दीजिए. यस सर, कॉपी कर रहे हैं.
कॉपी करने की जरूरत नहीं है, मैं दे दूंगा ना. You are asking me to show this slide for copying? No need to copy. I'll send you. Okay. Now come down. So one problem, just let me describe today, that how to integrate. So we are asked to integrate x square plus y square in xy plane, and the region R is given. What is the region R is given here? R is the region enclosed by the triangle having its vertices 0, 0, 1, 0 and 1, 1. So first, as in line integration, we first consider the curve C. Here you consider first the region. What is the region is given on xy plane? It is given on xy plane. So first vertices are 0, 0, 0, 0, then 1, 0, this is 1, 0 and 1, 1, somewhere at here, this is 1, 1. So the triangular region, this triangular region, so this is your R. You have to integrate along this region. You have to integrate along this region. This is the region. Along this region, you have to integrate. So how can you represent this region in mathematical way? So what will be your R? Try to clear. R is the point, all point xy, such that you can write that
Sir,
x
belongs to 0 to 1 and y belongs to 0
Why?
to 1.
is it true? Okay, x belongs to 0 to 1, correct. So as x runs from 0 to 1, y runs from here to here or here to here, 1. Try to make it clear. If you write x belongs to 0 to 1, x runs from 0 to 1, y runs from here, this x, from x-axis to this line, yes or no?
Yes,
The
sir.
y will run from 0 to x.
Yes, sir.
Y will run from 0 to x.
That is correct. First tell me, y runs from this line to this line, yes or no? Y runs from this x-axis to this line, x-axis to this line.
Yes.
So what
Yes, sir.
what is this line?
Yes,
What is
Yes,
this
sir.
line? Equation of this
Y
line
equals
is
to
what?
x.
Y equals to
Passes
x.
through 0 0 and
Y
1 1.
equals
So
to x.
To
y
x.
Y
equals
equals
to
to
x.
x.
So they can write the y runs from 0 to x. Yes or no?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now tell me, one can I represent in some other way this region? I am writing some of your friends. Suppose he is writing like this, that y runs from 0 to 1. I am writing y runs from 0 to 1. Y runs from 0 to 1. So y is running from 0 to 1, somewhere right here. Y runs from 0 to 1. And in that case, x run from this line to this line. Same thing, yes or no? So
Yes,
in
sir.
that case, x runs from this x runs from up to 1 from
0 to y.
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 So y less than equal to x, that's the law. Both are correct, yes or no?
Yes, sir.
Yes,
Yes.
sir.
So you can represent in any one of the way, either this way or this way. So once you represent this thing, then the thing will be easy. Now what you need to do, you can write integration over r x square plus y square dx dy, x square plus y square dx dy, that will be equal to what? Region R is subdivided at from x is equal to from 0 to 1, y is equal to from 0 to x square plus y square dx dy. Now I can write in repeated form. First, you see, so which one you integrate first? You see, as the limit here, as the limit is given x, so first you integrate with respect to y. First you integrate with respect to y, then with respect to x. So we integrate x equal to 0 to 1, write as repeated integration like this, y is equal to 0 to x square plus y square dy, then with respect to x. So now first 0 to 1. Now how will integrate this one? Y square, y will be x will be taken treated as
Constant.
fixed value, and fixed value we integrate with respect to y, so it will be x square y plus 1 by 3 y cube 0 to x limit, then dx. So that is from x equal to 0 to 1, this will be what? X, if you put x cube plus 1 by 3 x cube,
Y cube. X cube.
x cube, then if you put 0, it will be 0. So dx, that is 1 plus 1 by 3,
4
1
by
plus 1
3.
by 3, then 1 by 4. Integration of this, it will be 1 by 4. Now integrate, just simply integrate this one. I think you can do. So this will be 1 by 4 now.
Yes, sir.
So the value will be 3 is to 1, 1 by 3.
1 by 3 answer.
So the answer will be 1 by 3.
So 1 by 3 is the answer. 1 by 3.
Okay.
Sir, is there any criteria to put in the bracket like dy?
Yes, that I'm writing. Suppose first we have integration. If you take, now I am giving the task to you, that integrate this thing by taking this range over x. In that case, you see, you are taking the limit 0 to 1, then 1 to x, y to 1. So in that case, first we integrate with respect to x, then we integrate with respect to y. Okay.
Okay, sir.
And sir, the area of the triangle is 1 by 2.
I am not finding the area here of the triangle. You are not finding the area of the triangle. You are finding what? If you
Volume.
okay, volume. So what you actually are finding here? You are finding actually, if you write this z-axis like here, and if you draw this circle x square plus y square, some circle x square plus y square on this plane, you are indicating x square plus y square like this. Sorry, not like this. Sorry, z is equal to x square plus y square. Z is equal to x square plus y square. So if you, for each value on this point, for each value, each xy at this, you will get if some surfaces over this z, and then you're finding this volume. Actually, this volume you're finding.
Sir, how did we
bolo.
get that range of x is greater than y and less than 1 in the second part?
Which one?
Sir, here we have written below that diagram that y is between 0 to 1 and x is between y to 1.
Sir,
Sir, how did we get that?
How we are getting? Tell me here. You see, if first you are writing 0 to 1, over the y-axis we are going from 0 to 1. So as you going from 0 to 1, you have to represent this area. So as you are going from y from 0 to 1, so x runs from this line to this line. Yes or no? Run from
Yes, sir.
this line to this line. You first thing like this. Whatever the line equation, then we write. So running from this line to this line. So what is the line equation? Y is equal to x. That means it is running from x is equal to y2, and equation of this line is what? Parallel to y-axis. That is x equal to 1.
Yes, sir.
So x equal to 1. So running from y to 1.
Okay, sir.
Okay. So let me stop here today. If you have any query, then raise it. So for the time being, your task is to solve the problems, okay, related to line integration. I will give you in the next class. I will discuss 2-3 more problems on this double integration. Then I will supply you some problem on double integration.
Thank you, sir.
Okay. Let me stop here today.